In this video, we're going to learn how to solve these JAMB Physics repeated questions under dew point, humidity, and relative humidity. So we're going to practice with 10 repeated questions for this topic. Alright, so let's get started. The first question I have here says, the small droplets of water that forms on the grass in the early hours of the morning is, we have option A, fog, option B, dew, option C, mist, option D, hail. So the correct option in this question is option B, which is dew. Alright, so let's go to the next repeated question, which is this one. Next repeated question I have here says, the temperature at which the water vapor present in the air is just sufficient to saturate the air is, we have saturation point, we have dew point, option C, ice point, option D, boiling point. So the correct option to this question is option B, which is dew point. Alright, so let's go to the next repeated question, which is this one. It says, if the partial pressure of water vapor at 27 degrees Celsius is 18 millimeter mercury and the saturated vapor pressure of the atmosphere at the same temperature is 24 millimeter mercury, the relative humidity at this temperature is what? Alright, so guys, basically to solve this kind of problem under relative humidity, this is the basic formula you can apply to solve it. So you can apply saturated vapor pressure at dew point over saturated vapor pressure at room temperature, alright, times 100 over 1. So basically the one at dew point in this question we have here is, if the partial pressure of water vapor at 27 degrees Celsius is 18 millimeter mercury, the one at dew point is 18, so it will be 18 over, whereas the one at room temperature and the saturated vapor pressure of the atmosphere at same temperature is 24 millimeter mercury, so it will be 24 times 100 over 1. Okay, so let's punch this on the JAMB calculator you're going to see. So we have 18 times 100, divide this by 24. So we have the output was 75%. That will be the answer to this question, option A. Okay, so basically, even without making use of this formula, to easily get it in almost in all cases, just the least value over the highest value times 100 over 1 in terms of pressure. Alright, that's how you can do this. So let's wipe this now and solve the next repeated question. Alright, so the next repeated question we're going to solve will be this question. It says, the mass of water vapor in a given volume of air is 0.05 gram. Now we are dealing with mass and no longer pressure, okay, at 20 degrees Celsius, while the mass of water vapor required to saturate it at the same temperature is 0.15 gram. Calculate the relative humidity of the air. Alright, so this is my one. Now instead of using the formula of saturated vapor pressure at dew point, now you'll be using mass at dew point over mass at room temperature times 100 over 1, of which it will be the least over the highest times 100 over 1. So in this question, the mass at dew point will be, so the least value I will have it to be 0.05 gram over the mass at room temperature will have it to be 0.15 gram times 100 over 1. So let's punch this on this calculator. So we have 0.05 times 100. So divide this by 0.15. So we have the output be what, 33.0 33%. So the correct option to this question is option A. Alright, so this basically can solve this kind of problems. So let's wipe this now. Look at the next repeated question. Alright, so the next repeated question will be this question. It says the table above shows the saturation vapor pressure against temperature in a certain time. If the vapor pressure in this tank at 20 degrees Celsius is 10 millimeter mercury, what is the relative humidity? Alright, so for this particular question, we are going to make use of this one involves pressure and not mass. Okay, so to solve this question is going to be the way to give us the saturated vapor pressure at dew point, which is 10 millimeter mercury. So it's going to be 10 over. Now the saturated vapor pressure at room temperature will be, when you check at 20 cm at 20 degrees Celsius, we have the saturated vapor pressure to be 17 point. This place 17.50. So this will give us 10 over 17.50 times 100 over 1. So that's basically how you can solve this kind of problem. The least over the highest in the parameters we are using times 100 over 1. So let's punch in the calculator. This is going to give us 10 times 100, basically to give us 1000. So you divide this by 17.5, 17.50. So we have the output to be 17.5. Alright, let's verify again. 1000 divided 17.50. Alright, so we have the output to be 57.14. Alright, so the correct option to this question is option A. If we are leaving it to the nearest whole number, so if I want to know the nearest whole number, I'm going to have 57%. Okay, so the correct option here is option A, the 7.0%. That's it for this question. Let's wipe this now, so the next repeated question. Alright, so the next repeated question will be this question. It says the temperature of the air is 25 degrees Celsius and the saturated vapor pressure of water at that temperature is 31.67 kilo pressure. The partial pressure of water vapor in the air is 18.78 kilo. What is the relative humidity of the air? Alright, so that before we solve this question, if you are new to our channel, ensure that you are subscribed to this channel for more of our videos. We really appreciate this. Alright, so for this particular question, we are going to make use of the basic formula: saturated vapor pressure at dew point over that of room temperature times 100 over 1. Okay, so for that at room temperature, we have it to be 18, the least one there, 0.78 over that of room temperature is 31.67, okay, times 100 over 1. This is point. Okay, so let's punch this on the calculator and see what it's going to give us. So we have 18.78, alright, times 100. So divide this by 31.67. So we have the output to be 59.29. So if you are approximating to one decimal place, it's going to give you 59.3. percent. So the correct option is option D. Alright, it's as simple as this. Let's wipe this now, solve the next repeated question. Alright, so the next repeated question will be this question. It says, on a particular hot day, the temperature is 40 degrees Celsius and the partial pressure of water vapor in the air is 38.8 millimeter mercury. What is the relative humidity? Okay, now for this particular question, we still make use of saturated vapor pressure at dew point over saturated vapor pressure at room temperature times 100/1. Okay, so for this particular question, we are going for the relative humidity. So it will be the saturated vapor pressure at dew point now will be 38.8 millimeter mercury. Alright, so this will give us 38.8 over. Now, that at room temperature at 40 degrees Celsius, we have it to be 55.3. So, over 55.3 times 100/1. So that's basically all you have to do. Let's punch this on the calculator. This will give us 38.8 times 100. Okay, divide this by 55.3. So we have the output to be 70.16. If you are approximating to the nearest whole number, you get 70%. So the correct option is option B. It's as simple as this. Okay, so let's wipe this now and solve the next repeated question. Okay, so the next repeated question with this question, it says the reading above are for 3 consecutive days for a wet and dry bulb hygrometer. It can be concluded that the relative humidity for the 3 days is option A was least on day 1, remained unchanged, decreased steadily, increased steadily. So guys, when you solve this problem, you are going to I have solved it already, but because of time, the correct option will be option D, which is increased steadily. Just take note of this question. Alright, so let's go to the next question, which is this one. It says on a certain day the average air temperature was 35 degrees Celsius and the dew point was 10 degrees Celsius. If the saturated vapor pressure of water vapor was 18.4 millimeter mercury at 35 degrees Celsius and 11.2 millimeter mercury at 10 degrees Celsius, find the percentage relative humidity of the air. Alright, so for this particular question, is going to be the saturated vapor pressure at dew point. In this question, we have it to be 11.2 over at room temperature is 18.4 times 100, alright, over 1. So that's how you can solve this problem. Let's punch in the calculator. We have 11.2 times 100. Alright, divide this by 18.4. So we have the output to be 60.86. If you approximate it to 1 decimal place, it will give you 60.9%. So that's the answer to this question. The correct option is option A. Is as simple as this. Alright, so lastly, before we call it a video, let's look at this question. Question 10. It says, at low humidity in an environment, the human skin is usually A. damp and smooth, no. B. damp and rough, no. C. dry and smooth, no. D. dry and rough, correct. So the correct option in this question is option D, which is dry and rough. So this basically can do problems involving dew points, humidity, and relative humidity for JAMB Physics. Hope you learned something interesting from the video. Let's go to the video, guys. If you are new to our channel once more, ensure that you subscribe to this channel for more of our videos. Also like, share, and comment on this video. Let me know if you for what you learned from this video. If you seem to have any specific questions to ask, I don't know what I've talked about in this video, feel free to leave a question in the comment section below and I'll be sure to give you a response. Also, ensure that you're part of our channel membership by clicking the join button to become part of the community. The area we share special information and helps to simplify academic problems for members of the channel. So join us now, and if you like it, having known that, click the screen above, and I see you in the next video. Thanks for watching.